will be your host and moderator on behalf of Virtual Building Studio. I welcome you all. So, at Virtual Building Studio, we help contractors, consultants, and AEC firms transform complex building systems into coordinated, construction ready BIM deliverables. By combining deep MEP expertise with scalable delivery teams, we help reduce rework, improve collaboration, and support projects from pre construction through project handover. Before we begin, a few quick housekeeping items. This session is being recorded and will be shared with all registered attendees following the webinar. We encourage you to submit questions through the session using the Q&A feature. We'll reserve time towards the end for audience questions and discussion. If we don't get to your question during the live session, our team will ensure it reaches our speaker afterwards. Over the last few years, we have seen data centers evolve from supporting cloud applications and digital services to becoming the backbone of the AI economy. The rapid rise of generative AI, large language models, and AI training workloads has fundamentally changed the scale, and complexity of such delivery requirements. What was considered an aggressive deployment schedule just a few years ago is now becoming the minimum expectation. The question facing the industry today is no longer whether we can build more data centers, but rather how do we build them faster, smarter, and with greater predictability. Today's session, Building the AI Universe, Productized MEPF Design, and Retail Delivery for Data Centers, explores exactly that challenge and, more importantly, the delivery models emerging to solve it. Whether you are an owner, design contractor, or technology partner, today's discussion offers valuable insights into the future of scalable data center delivery. It's now my pleasure to introduce today's speaker, John Benson. John serves as the Director of the Modular Innovation at TAS Energy, where he works with some of the world's largest AI data centers and developers to advance modular infrastructure delivery strategies. His experience spans engineering, procurement, sourcing, manufacturing, and project execution, giving him a uniquely comprehensive perspective on how industrialized delivery models are reshaping mission-critical infrastructure products. He also serves as a key market expert with TAS, helping organizations understand the rapidly evolving dynamic AI infrastructure demand and delivery. John, we are delighted to have you with us today, and we look forward to learn from your experience at the forefront of AI infrastructure delivery. Welcome, John. The stage is yours.
Thank you very much. Are we good for sharing? Just making sure. I think I see
Yes.
it, but
Yes, we are.
perfect. Okay.
Yeah.
So thank you everyone for taking some time today to listen in and hopefully have a little bit of discussion on building the AI universe, especially as it pertains to productizing and industrializing the building of these repeatable data centers. So before I get started in that, let me just give you a little bit of background of the company and also of myself. So TAS Energy was founded in 1999. It is currently owned by a large conglomerate of contract. The company owns a large conglomerate of contractors, which is Comfort Systems USA. It's one of the largest contracting consortiums in the United States. TAS is a manufacturer of very large integrated modular infrastructure, primarily focused on MEPF type systems. We are a strategic partner to owners who are building the AI universe, and some of the largest owners on the planet, if you will. And currently, TAS is slated to have a modular manufacturing platform approaching 4 million square feet by the end of 2027. So a pretty significant player in the modular integrated system space. Now, as for me, I I am someone who has more than 30 years of experience in the MEPF arena. As was stated earlier, I've done a lot within this space. I've spent about 20 years in the modular infrastructure manufacturing space. I've also owned my own energy infrastructure development company. I've worked for OEMs, and I've also served as a construction services provider. So as mentioned earlier, I've kind of seen the gamut in terms of experience and understanding of the market itself. So let's jump to what our topics are for today. And there's really four things that we're going to focus on throughout this conversation today. First is the challenges of building these AI factories. The demand is unprecedented, and there's some real challenges in doing that, and we'll talk a little bit about that. The second thing is to talk about what is the next generation delivery model for these AI factories, for this industrialized construction. The third item is to talk about the necessity of offsite manufacturing. And this isn't necessarily something new per se, but it is something that has become a very, very pronounced element within the building of the AI factory of 2026 and beyond. And then finally, we'll talk about reframing the stakeholder responsibilities for how we do this. And the fourth item will really be sprinkled throughout the discussion, focused on the other three items, but we'll kind of bring this all to a conclusion at the end. So with that in mind, I want to start with a poll question, and I'll ask the moderator to prop up the poll question so we can take that on. Okay, are we good at the poll? Not yet. Okay. So moving on, let's start with the market challenge that we're facing today with the building of the AI universe. And we'll start with some general things and then get into some of the data. But if you look at a lot of the headlines that are occurring, and these were pulled from things throughout the first part of this year, there's a lot of things talking about how this is driving the global economy. It's obviously driving the global tech industry, but it is driving the world right now. And one of the interesting features of AI, the AI build, is that it is literally propping up the global economy. And it will drive the global economy from now until we're not here anymore. So there's a lot of things that are going on with the AI universe, and there's a lot of things that we have to understand about this, because this is an unprecedented opportunity. It's doubtful that there's been anything approaching this in the history of the world. It is not on the same scale as anything we've seen before. So let's talk about what that translates to in terms of dollars and capacity. And we'll start with the CapEx investment that's projected using the past 3 or 4 years of data, and then projecting forward where are we going throughout the rest of this decade. If you look at the first 4 years of AI, starting in 2022, because that's really when ChatGPT kind of came into our our conversation, we've seen about $2 trillion of investment between 2022 and 2025. In 2026, we're actually going to cross the $1 trillion threshold on an annual basis for investment in AI. And if you look at the kind of the breakdown, the four major players in the tech space, Amazon, Alphabet, Google, Meta, and Microsoft, are going to spend somewhere around 800 billion of that $1.2 trillion this year. And that number is only going to continue to increase. By 2030, it's projected that that number will approach $2.5 trillion, which by projections is about 2% of the entire global economy, which will be projected at somewhere around 140 to 150 million or 150 trillion dollars. So that's a pretty significant chunk of the total gross domestic product of the planet. And that does kind of say to people, why are we doing that? Well, why we're doing that is the projection that's out there for how much IT equipment will be needed. This is the IT equipment procurement projections, actually the reality and the projections. And if you look at this chart, we're looking at this year alone, the demand for power will be about 35 gigawatts. And that blue piece of the chart is the four major companies, again, Amazon, Alphabet, at Google, Meta, and Microsoft. So those four companies alone will be about 25 of that 35 gigawatts. That's a pretty significant investment in IT infrastructure for those companies. And if you look at the backlog that NVIDIA announced last week, they're saying that they have $1 trillion in backlog through 2027. That equates to about 25 gigawatts. And if you look at 2026 and 2027, that's kind of along the lines of how much is there, and there will be more. And so it's really a significant amount of stuff that needs to be powered, cooled, protected, etc. So there's a lot in this that needs to be done to support that IT procurement. So people throw the word gigawatt around, and I often challenge people to say, do you understand what a gigawatt means? And they say, well, yeah, I mean, I do. Do you? I mean, it's kind of an interesting discussion, because a gigawatt is a lot of stuff. And a gigawatt of power is, that's a lot. That's a million kilowatts. That's a billion watts. That's a lot of ovens. An oven is about 500 watts. So that's, some 200 million ovens. That's a lot. So, you really have to start thinking about, it's not just a word. You have to think about what that really translates to. And so I have this short video clip that kind of demonstrates the scale of the infrastructure that's needed to support a gigawatt. And if you watch this truck this is rolling out of one of our facilities, that truck houses about 1/1000th of a gigawatt. It's about 1 megawatt of equipment. So in order to provide 1 gigawatt of infrastructure for the data center itself, you need about 1,000 of those truckloads to do that. And as this plays, you can look to, get it to play here, there we go. You can look to the right and to the left, and you'll see some structures there to the right and left of the truck that reflect what about 1/12 of the infrastructure needed for 1 gigawatt is there. And that's about 300 feet long and about 150 feet wide of stuff that's needed to supply a data center of 1 gigawatt. That's a lot of stuff. That's only 1/12 of what's needed. So putting that in context, it isn't just a number that people can throw around to say, oh, we're going to put 10 gigawatts of stuff. Man, that's a lot of stuff. And the challenge is that there's people that are out there saying that we're going to do these things that they'd have no experience doing. And that's part of the challenge of how we're going to build these massive quantities of infrastructure going forward. So with that in mind, let's move on to the second poll. Okay. Thank you, everybody. So let's move on to looking at what the next generation delivery model looks like, because there are some very significant changes as we move into building this AI universe. And we'll start off by looking at one of the core pieces of the data center and what that requires, and that's the IT equipment power roadmap. And if you look at just starting, a year ago, 2 years ago, and today, you can see that there's already a fairly significant increase from tens of kilowatts of power per cabinet to something over 100, 150 kilowatts per cabinet. And you can see that in a standard cabinet by 2030, that number is going to increase to 500 kilowatts. That's an insane amount of power in a very, very, very small space. Now, the absolute crazy part is there's this thing called an ultra cabinet that will start coming out in 2026 and early 27, where we will start seeing about 600 kilowatts in a single cabinet. And by 2030, they're projecting that could go as high as almost 2,000 kilowatts per cabinet. That's literally like sticking 4,000 ovens in a cabinet the size of one. So if you're loading 4,000 heating elements for an oven inside of one cabinet, that's about what you're talking about. So it's just an insane amount of power. It's an insane amount of cooling. It's literally just an insane thing to deal with. And the infrastructure to support that is incredible. And we'll talk about that next, which is how is this shift to changing the makeup, the land space makeup of a data center. If you look at the square on the left, that's a data center circa 2018. And the white area in that is the area in which the IT equipment exists. The gray area is the area in which the MEPF systems or the MEP systems exist. And it's about 35% of the total. There's about 35 to 65 for the IT equipment to the mechanical space, mechanical electrical space. So that's a pretty decent ratio. I mean, that was pretty manageable. If we fast forward to 2025, 2026, we're looking at a fairly significant change in the amount of the size of that data center, if you will, and the change from about 30 or 40 megawatts in 2018 to somewhere approaching 100 megawatts in a single block in 2025, 2026. The other thing is that the proportions have changed. Now the MEPF space or the MEP space is taking up about 70% of the land usage for that data center. So that's a pretty significant change. If we fast forward to 2030, the proportions just go kind of off the chart. That block is somewhere around 200 to 250 megawatts. And the IT equipment space is less than 10% of the total. So you've got this massive amount of infrastructure feeding into a very, very small building. So if you've got 100,000 square feet of space, you're talking about a building that's under 10,000 square feet, and you need 90,000 square feet, or about 2 acres of land, to fill that that data center. So the MEPF infrastructure is becoming an all-consuming part of the data center itself. And that's why it's so important to talk about how we change this from construction to industrializing the construction. And that's really the shift that we're looking at. Is today building an AI factory demands that we shift our focus from a single project construction mindset to a very repeatable manufacturing mindset. How do we do this in an industrial manner? And that's really the crux of what we're going to focus on the rest of this discussion. So let's talk about first the paradigm shift that's going to be required in the design. So data centers are basically now repeatable data warehouses. It's literally a warehouse building or a distribution center type building with, these very, very intense IT cabinets and a whole lot of MEPF systems to support it. No longer are these really site-specific, creative, innovative, thoughtful designs. No, this is pretty much you cut out your cookies and put them on the baking sheet and away you go. So the creativity in this is being pretty rapidly devalued. The other piece of this is that there is a massive shift occurring to offsite manufacturing of these large integrated systems. We simply can't build the quantity of MEP systems that are required with conventional means. It's just not feasible anymore. So the design shift the paradigm shift for the design is to focus on early collaboration with these integrators and having the necessity of being able to design these systems for deployment everywhere. And whether it's in Rome or Frankfurt or Amsterdam or London or Northern Virginia or Phoenix or Dallas or Portland or Singapore or Tokyo, those kinds of systems are going to have to be deployed in an everywhere mentality. So we're looking at things that can literally be deployed in many, many different places. And there are some things that we have to look at in that. If you're designing something for Peoria or for Santiago, Chile, those are very different. And we have to be able to accommodate all of those locales with the same basic framework of equipment. So from a design perspective, those are some fairly significant shifts. Now it gets more complicated on the construct side because, again, we're taking this idea of, well, I need to put all of these very specialized skill sets onto a site and taking away that requirement. Construction's now largely civil and general on data center sites, at least at the hyperscale level. That's becoming less and less MEP focused. So we do need to look at massively moving the number of people involved in MEP systems and the hours that they require offsite. That's just the shift that's happening. Larger integrated systems are absolutely the rule today. They are not the exception. 10 years ago in 2018, those were absolutely the exception. They are not anymore. There is a significant reduction in the dependence on skilled trades. They're just not available. And we'll talk about that a little bit further down. But that shift is happening at lightning speed. And now there is more dependence on expertise in how you install these large integrated systems. That's not as simple as, oh, hey, I'll just send you some information and drawings and, here you go, have a nice day. It's not like installing a piece of equipment. There is a lot more to it. There are a lot more interfaces. There are a lot more challenges in that. The pieces are much, much, much larger. And we see that every day in our business. The challenge of, educating the tradespeople on how to install and commission these very large systems. I probably spend more of my time doing that than working with the clients on how to coordinate this, buy it, et cetera. So a major shift on the construct side. The other piece is that there's a huge paradigm shift on the develop side. There is a reducing reliance on the OEMs, on the AE companies, and on the contractor companies, because a lot of this is moving to the integrators, to the industrial manufacturing, industrial construction sites, and that shift is, again, happening very, very rapidly. So there is this increased reliance on these integrator companies, and that's where a lot of the design and procurement activities are occurring within the owner sets that are rapidly deploying this. There is that procurement shift from single project to long-term programs, and we see that currently. I mean, the number of clients that are looking out to the end of this decade to secure procurement of, equipment, integration systems, et cetera. Those are all happening right now. And the people that aren't doing that, aren't looking long-term, they're going to be, really scrambling to make that work. And here's the mentality shift. You are building factories. You are not building buildings. And there are some, especially in the hyperscale realm, that have that understand that are deploying that understand that. There are many others who are trying to figure that out and haven't quite gotten to that fact, because they still look at it as if they're building buildings, and you're not. You're building a factory. So there's some pretty significant paradigm shifts that are occurring, and this is just within the last 2 to 3 years. And it's really important to understand how that impacts you, because it is, and it will continue to, and you will have to adapt. So let's take the question number 3 poll, and this is more trivia than it is a poll. So we'll have to see how many people get this right. Okay, is everybody's answer in? The correct answer is C, 2006 to 2010. And the points of data that I have are that TAS built the first modular MEPF system for data center in 2006. And the first modular data center was built by Sun Systems in 2007. So that's really the first deployments of modular at any kind of scale. So let's move on and kind of finish our major topics here, and that's the necessity of offsite manufacturing. And obviously this is a topic that is near and dear to my heart, but it's been changing over the past few years as we've been ramping up to grow into this AI boom. And it really is requiring us to rethink, even within the manufacturing side of the business, how we do these things and how that then translates to the people that are outside of that manufacturing environment. So let's start with something that's really, really important, and I kind of alluded to this, but we do have a trades deficit, not a trade deficit. We have a trades deficit, and if we look at currently, you've got about 20% of the skilled tradespeople are over the age of 55 and are rapidly retiring from the industry. When you hit about 50 to 55, if you've been in the trades for that long, your body just wears out. I mean, it's a very, very difficult job to continue much past the age of 50. And that leads us to this idea of this 5 to 2 gap. And what the 5 to 2 gap is that for every 5 tradespeople that are retiring, there are exactly 2 to replace them. So that gap is continuing to widen over time. Currently, we're looking at something around 500,000, a deficit of about 500,000 people to meet the demand for today. And that's why this shift toward offsite manufacturing is an absolutely essential need for building the AI universe. We just don't have enough skilled people to go on sites to do all of the work that's required. Now, this gap is going to continue to widen because by 2030, they're projecting that over 2 million trades positions will be unfilled. And the price tag on that will be $1 trillion a year. And that was an article by Fortune just a couple of months ago. So this trades deficit is really a big driver, but it isn't the only driver. It's how do we build these things faster, less expensively, and with higher quality. Now, there's an interesting point that I can make based off of my own data. And if you look at this chart, this is actually the number of shipped items that TAS is, or the number of items that TAS has shipped over its history, starting to about 2000, all the way up to projections into 2027, 2028. And to the left of the dashed line is what I call the business as usual case. That was when offsite construction, modular construction, prefabrication construction was kind of a niche. And I call that business as usual. And from 2000 to 2022, there's a fairly small growth. And not insignificant, but by comparison to today, it's pretty insignificant. If we look at the growth in 23, 24, 25, we're starting to get onto, an exponential type growth curve. As we get into 26, 27, 28, and beyond, this thing is absolutely going exponential. This is on a power curve. And that is directly attributable to AI, period. That is absolutely the driver for the industry shifting to offsite construction. And that will continue in many, many other markets as we go forward. And the demand for power and other support systems has really put strain on the trades. And this is going to become a really important part of every construction effort from here until 2050. So that's what we can see today, and we have the data to support that. But it is real, and it is happening right now, and has been happening for the past 3 to 4 years. So the people that missed the ship in 2023, I get asked this question very frequently. That it's like, well, is it too late to get in? Well, the ship sailed, and if you want to catch up to it, you better do some extraordinary things to get caught up, because you've got about a 3 or 4 year learning curve to get on just to catch up to today. So that's why discussions like this, I think, are really important for all of us to have. try that again. So let's talk about some of the specifics in, looking at this offsite manufacturing for this large infrastructure. And if we look at a few things, we'll start with the design for manufacturing. The design for manufacturing really combines art and science. And the science is pretty straightforward. The art piece is a little more tailored and specific to manufacturing. There's an art to design for construction, and there's an art to design for manufacturing. And if you're trying to broach that gap, you really need to understand that manufacturing and construction are not the same thing. And there are some very significant differences between the two. I see people all the time trying to design for manufacturing and assembly, DFMA. And when you're designing, accustomed to designing for construction, designing for manufacturing will get you into trouble. And so you really need to understand the mindset of the manufacturer before kind of jumping into that realm. The reasons for that is that the design for manufacturing is far more precise and far more detailed than construction design is. This has to be down to the millimeter of tolerance and how we can design to build to that. You need to design for not just the product, what's the end result, but also the processes that you're using for doing that manufacturing. You do have to have a mind toward integrating for the automation that invariably will be used. You can't assume that the automation, we'll have automation there, so we'll just figure out how to make that work. No, you have to integrate the automation in before you actually start designing. You've got to understand what that looks like. It's not an afterthought, it's a wholesale integration. You also have to be adherent to the processes of the manufacturing. When you get into a manufacturing environment, it's not okay to just say, well, we'll figure that out in the field. We'll make that up in the field. Somebody will figure that out. Somebody will do that, that clash detection. Somebody will figure that out. Can't do that in manufacturing. We don't have that luxury. If this thing shows up on a site, there is no forgiveness. There is no correction. It's either right or you've got a massive mess on your hands. And the other piece of this is that you've got to standardize the materials because you're moving such a high volume of product that you really have to be focused on, are the materials that we're using, can we get them in the scale? And why wouldn't we just use the same material instead of saying, well, this material is exactly what I need for this job? Well, yeah, but can I get away with using this other one? Well, sure, I can. Maybe it's 3 cents more that I have to spend. Well, in a manufacturing environment at high volume, that 3 cents will actually save you probably 10 to 15 cents. So, spending 3 pennies more on material will save you in the long run and allow you to produce more product. So there's a lot of differences between design for construction and design for manufacturing. And those are some of those highlights. The other thing that we talk about is the owner procurement. And this really gets into kind of how we have to think about design and how we have to think about programming and, how standardized can these things become? Because again, we talked about designing for everywhere. This really plays into that. If we're looking at a standard project-based schedule, the blue line, as a building or a specific, site ramps up, ramps down, there's a lag until we're ready for the next one, and then we start ramping up and ramping down. Well, the ramping up and ramping down, that's people, that's materials, that's all kinds of things that have to occur. And that translated to a manufacturing environment is even more pronounced than it is on a construction site. I mean, I can throw a whole lot of people at, a problem, at a situation on the site, and they probably don't interfere with one another. In a manufacturing environment, I need to flatline that, and that's the orange line. That's what we really need to do, because I only have a certain amount of space that I can build in. I only have a certain number of people that I have. I only have, I have to put out a lot of product in that. And so the program planning versus project procurement is a big deal. And the flat schedules are an absolute imperative for this.
Excuse me, John.
Yes,
Uh, I believe your presentation has stopped for some reason. Can you reshare the presentation?
I certainly can. My apologies for that. Okay, let's try that. Are we sharing again?
The video is back,
Okay.
and the presentation too.
Okay.
Great.
I don't know what happened. So where did I lose that on?
Um, yep. This was the page, the last 2 points, I believe.
That was the last one?
Yep.
Okay. Okay, so we just missed this slide. So that's the slide I was referring to, the blue line and the orange line. It wouldn't make sense without the slide. So for some reason, it wanted me to leave the presentation. So I'm not sure why that was. So again, my apologies for that. But again, the schedules being flattened are really, really important. And the challenge of doing that does raise some additional items. But the conversations about flat loading the sites and the manufacturing actually can provide some benefits to everybody, and it actually can smooth out some schedules. So there's really some significant reasons to do this, not only just for the manufacturing side, but also for the site side, and it does impact us kind of across the board, from design, commissioning, all of those things. So it's a really big shift that people are trying to wrap their heads around today. And this is the crux of every conversation that I have with an owner today. So let's move on. The other thing in a manufacturing environment is material procurement. And the big issue here is, what do I have to manage? If I'm short of something on a site, I can send somebody on a run to maybe go to a supply store or Home Depot or Lowe's or a hardware store or something. When we're doing high volume manufacturing, no, we're not doing that anymore. You can't do that. That's a no-no. And so material management in the manufacturing environment includes everything. That's from big equipment to big pieces of material, steel, aluminum, copper, whatever. It also goes back to this idea of standardization, because you want to manage a higher quantity of fewer things. And that's really, a move that, again, it affects the design, it affects the procurement, it affects a lot of different things that have to be accounted for. And even down to the fact that you've got nuts and bolts that need to get, QR codes to be tracked. It seems kind of silly to do that, but when you realize that if you're missing a box of nuts and bolts for something and you don't have that, or it gets misplaced, you grind an entire manufacturing operation to a halt. And that becomes a much more significant issue for manufacturing than it is for construction. In a construction site, there's plenty of things that people can do. I can move people to a different site, to a different part of the site, to a different task, to a different activity. That's great. I don't have that luxury in a manufacturing environment. It's very difficult to move people to another task, because all of these things are happening like a symphony. And if all of a sudden the violins start playing a different tune, the whole thing just kind of crumbles. So this is a really big deal that people don't see, but it is impactful on the design side, and understanding what it is that you're getting, that there may be some standardization in this, that you say, well, yeah, why are you doing that? Why are you spending another $10 to do this? Well, because I'm going to make sure that I can meet the schedules, that I can meet the quality, and all of those things. So there are some other factors that come into play. So this does become a big deal for the manufacturing side. The other piece of this is automation, and there's kind of two plays to this. One is automation as a workforce multiplier, and the big thing is using robots and robotic welders and robotic this and robotic that, and the robots are only part of the process. So you really have to understand what is the total impact to this. So the interesting thing is that this isn't just, hey, the robots take 5 minutes to do what they're trying to do. Yeah, I still have to set that up. I still have to have somebody put that on that fixture. I still have to have a lot of things that happen ahead of that. And yes, the robots are taking activities that would typically take hours and doing them in minutes. And this is probably a 5 to 6x. This will 5 or 6x the number of people that would normally be doing this, and increase the throughput by 5 to 6 times. It's a very significant enhancement, but you also have to do this in a way that makes sense. And that's why the repeatability is so important in the manufacturing environment, because every time I have to reset, the robots, I have to reprogram them, I have to do those things, I lose all of that productivity. And those are the things that people don't necessarily account for. And oh, by the way, if those robots are sitting idle for a couple of months, yeah, that's probably a bad thing. So that investment just tanked. So that's, so automation as a workforce multiplier is key, but you can't just assume that that's going to be happening everywhere. You have to plan that into all of your activities. You have to plan that in from the beginning, how you're going to do that. And that's why the previous things were so important. Now, automation as a precision maker is becoming even more important today. And if you look at some of the technologies that we are deploying for this, robotic welding with AI guidance. And there's actually a camera on every one of these welding robots to track that weld. If that material was off by just a little bit, maybe a couple of degrees, well, that robot is just going to take that down a straight line. And if you miss that weld gap, that gap between the two pieces of material, well, now you have to redo that. And that's either a throwaway or you have to do some significant rework on that. So the AI guidance on this has taken the amount of rework down to almost zero. I mean, I don't think it'll ever be perfect, but it's pretty darn close. So that's really a big deal. But again, you can only do that in a manufacturing environment, and you can really only do that at scale. And those are the kinds of things that you really have to look at in this. Why do we have to shift to repeatable things? Why do we have to flatten out schedules? This is why, because this is where the payoff happens. The other thing that comes into play is the use of lasers for all of your cutting. I think ideally we would like as a company to get to the point where we're not using a physical saw, a cutting blade anymore, and just use light. We probably won't get there, but we're making a rapid movement to largely get away from, any kind of mechanical cutting, and everything's being done with light. And the amount of precision that you can get is incredible. I mean, you're talking about, sub-millimeter kind of precision. And the quality of the cuts is absolutely astounding. You can cut in, dimensions, angles, shapes, sizes. I mean, you name it, it can be done. And the other thing is that you can bring in these automated material handling systems so that the material is placed exactly where it needs to be, and you get to the end product that you really want. Process for precision, this is an all factors piece. There's nothing that you get to do that's not part of the process. Close isn't even close to good enough in a manufacturing environment. In construction, you can take out a sledgehammer and start, bang, 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 and move some stuff around. You don't get to do that in a manufacturing environment. And then finally, safety still matters the most. And if you look at manufacturing versus site construction, the injury incident ratio is about 10x that of manufacturing. And I think ours is probably much lower than that. So it's probably a 10 to 15x reduction versus site construction. But that's another piece that it's hard to quantify that as as a site operator. But let me tell you, the owners, that is a massive, massive deal. So that fact alone is pretty significant. And people kind of forget about that. We don't. That's our most important piece. So kind of to wrap this up and talk about how we reframe the stakeholder roles. We talked about a lot of the paradigm shifts and other things that are happening, but there's 5 real things that I want you to take away from this that, kind of use as a thought discussion. Is first of all, to think like a manufacturer. As this shift is occurring, that's going to be much more important for every stakeholder in this. Repeatability is paramount, period. That's just not even open for discussion anymore. It's function over form. Cookie cutter, good enough is good enough, and it doesn't have to be perfect. And pretty isn't really important anymore. It's how do I get this done really fast? Collaboration is non-negotiable. I mean, the collaboration between all the parties is absolutely essential. And then adapt to the new, because this isn't coming. It's already here, and it's very widespread. And if you haven't seen it yet, it will start affecting you very, very shortly. So with that in mind, we have time for one last poll question, and then we'll open up for questions. So there's a few questions here. How are we doing on time, Mr. Moderator?
We are good. We have around 4 questions, as I can see.
Okay. I'll kind of tackle these, I guess, in order, because let me go to the last one first. It says, are you building fully built out structures with MEP, racks, and gear and boards all pre-wired? The answer is yes. So that one's easy. I'll tick that one off. The next one up is, do you see the facilities going vertical 2, 3, 4+ stories in height to maximize facility footprint? In some cases, yes, depends on the geography. Here in Singapore, they're going higher than that. I think, the challenge of going much beyond 2, the cost just goes off the chart. 3 is probably the practical limit. 4 is, it generally doesn't make sense in the US. And today, a lot of these are being built in, on farm prairies. So yeah, they're single, maybe 2-story. So that's, that's what I see. And, there's people that can say, that they're going to do it a certain way, but that's generally speaking the direction. So I mentioned that OEM providers are becoming less relevant. Wouldn't the integrators now be considered an OEM? By my definition, an OEM is somebody who is the original equipment manufacturer for the things that are being integrated. So the mechanical equipment, the electrical equipment, those kinds of things. The integrated system, yeah, I guess, we would be considered an OEM in that perspective. But, like I think the case here was, with the integrators buying major cooling components directly from the manufacturers, yeah, those are the people that I would consider to be the OEMs in this arena. So I think that's probably all I have. Oh, okay, got a few more here. We're shortlisted to create mobile modular data centers, and they need a consultant to assist on MEPF engineering, fabricate light gauge steel. Our structural engineering computer. Can you assist on all else? You'll have to contact me directly about that, because that's that will be an interesting question to answer. So I don't have an answer to that right now. Oh, what is the percent of water cooled to air cooled systems? It's about 10 to 90. 10% water cooled, 90% air cooled. Maybe slightly more, but the vast majority, I think, because water is such a politically charged issue, that air is definitely preferred. So I think that's all the questions that I see on there. Or I don't know if there's more. Who's going to raise their hand and ask a question?
Well, I believe that was the last question.
Okay. Perfect. And
Yes.
I will publish the answers for that. But yeah, those are my quick comments on all of those questions.
Thank you so much. So, I believe that concludes the session. So, John, thank you once again for sharing your insights and expertise with us today. Your perspectives on productized MEPF design, industrialized delivery, and the future of AI infrastructure have been incredibly valuable. And thank you to everyone who joined us for today's session. On behalf of everyone at Virtual Building Studio, we truly appreciate you spending your time with us. A recording of today's webinar will be shared with all registrants shortly. As the demand for AI infrastructure continues to accelerate, conversations like this become increasingly important in helping our industry rethink how we design, manufacture, and deliver the next generation of data centers. We look forward to welcoming you back to one of our future webinars. Until then, stay curious, keep learning, and have a wonderful day, everyone. Thank you.
Thank you so much.